Welcome. This lesson is to determine whether a system of linear equations has one solution, no solution, or infinitely many solutions. Now, you did do one right before the Christmas break where you had to graph them to see if it was the same line. If the two equations ended up being the same line, then it had infinitely many solutions. Or if the two lines intersected, weren't parallel, they had different slopes and they crossed at some point and had one solution. Or if they were different lines, but they were parallel and never intersected. So this lesson is to learn how to do that without having to take the time to graph it. But it all comes down to writing your equation in slope-intercept form. Y equals mx plus b. So you might be given two equations like 3x plus 7y equals, I don't care, 28. And maybe another equation like 2x minus 6y equals 24. Okay, and you're going to be asked, does that have one solution, no solutions, or infinitely many? What you will do is you will get these both equations into slope-intercept form if they're not already in slope-intercept form. Once they're in the slope-intercept form, we'll talk about it. So let's first get these into slope-intercept form. First thing I'm going to do is I'm on the top equation is I'm going to minus 3x from both sides of the equation, which leaves me a 7y equals a negative 3x plus 28. Then I'm going to divide by 7. Divide by 7 all three terms, which will leave me a y equals negative 3 over 7 times x plus 28 divided by 7 is 4. So I went from this expression to this expression by doing two simple steps. Minus the 3x to get it off the left side of the equation. Then I divided by 7 every term to get the 7 out from in front of the y because I want the y by itself. Now let's do the same thing to the bottom equation. First thing I'm going to do is minus 2x from both sides. That leaves me a negative 6y. Don't drop your negative symbol. Equals a negative 2x plus 24 because they're not like terms, just like up here, I didn't combine them. Now I'm going to divide everything by a negative 6. And that's going to give me a single y on the left of my equation. Negative 2 over negative 6 will be a positive 1 over 3 because that reduces. 2 over 6 is 1/3 times x. 24 over 6, that's a negative 6, by the way. It's going to become a minus 4. So now that we have them in slope-intercept form, I first ask, are the slopes different? If the slopes are different, then you have one solution. I don't care where the lines are at. If the slopes are different, they're eventually going to intersect and have a point in common. So for these two equations, you would say there is one solution because the slopes are different. Okay? Now, let's do another one. Let's do something like 5x plus, I don't care, y equals 18. And then I have something like, let's do, I don't care, 15x minus, no, let's do plus 3y equals, I don't care, 6. Okay. Again, the first thing we're going to do is we're going to solve for y. This top equation is only one simple step. I minus 5x over, because that leaves me a single y equals that negative 5x plus 18. The y is all by itself. That's in slope-intercept form. Y equals mx plus b. Now let's do it on the bottom equation. I'm going to minus the 15x over, That leaves me a 3y equals a negative 15x plus 6. That's the 6 here, negative 15x plus 6. Now, y is not by itself completely, so I got to divide everything by 3. And then that's going to give me a single y on the left of my equation. Negative 15 over negative 3 is a negative 5x. 6 divided by 3 is a 2. So here's the one equation written in slope-intercept form, and here's the other equation. Now, if you'll notice, the slopes, sorry, you can't see the y-intercept there, but if you'll notice, the slopes are the same. If the slopes are the same, negative 5, or I don't care what the slopes are, but if they're the same, they'll either be parallel or it'll be the same equation or same line. But we look now at the b. Is it the same exact equation? No, the b values are different, which means they're parallel. They never intersect. That means this one has no solution. The last scenario is if they would have infinitely many solutions, and that's going to be something very simple. They'll give you something like 3x plus, I don't care, 12y equals 48, and then they might give you something like 6x plus 24y equals 96. And they kind of look different. But if you go to solve them, first thing I'm going to do is minus the 3x over. That leaves me the 12y equals minus 3x plus 48. Now I'm going to divide everything by 12. And I get y equals a negative 1/4 x plus 4. Again, I'm sorry you can't quite see that. There we go. Now the second one here, again, minus the 6x, minus the 6x. So that gives me a 24y equals a negative 6x plus 96. Now I divide everything by 24. That leaves me a single y equals negative 6 over 24 will be a negative 1/4 x. Positive 96 divided by 24 will be a plus 4. And now I notice that the slopes are the same. The y-intercepts are, it's the exact same equation. If it's the same equation, you have infinitely many solutions, infinite solutions. So again, it's getting down to the slope-intercept form, y equals mx plus b. If the slopes are different, one solution. So write that down. If the slopes are different, one solution. If the slopes are the same, but the b value is different, then there's no solution. So again, if the slopes are the same, but the b is different, there's no solution. If the equations are completely the same, if both m and b are the same, then they're infinitely many because it's the same equation. If you have any questions, please bring them to